All right, so moving on to the second section here. We've just went over alcohols, and just to refresh you, you need to finish number 18, 19, 20. It does say it in your question booklet, but just in case you are not sure what to do there. So we're moving on to carboxylic acids. It says vinegar or ethanoic acid is a carboxylic acid. This is one that you would know in your everyday life. Take a look at the structural diagram of vinegar and think about how it's different than an alcohol. So when we look at an alcohol, we always see OH. Yeah. NOH, that means that it's an alcohol. But something that makes an carboxylic acid different is that it also has this double bonded O. Right? So the double bonded O tells you that it is a carboxylic acid. It's an alcohol with an extra double bonded O on the end. So if we go back to our data booklet, we will see that. So on the very end of the molecule, you got a double bonded O and then a single bonded O, right? And that makes a carboxylic acid. This is the vinegar one, which is ethanoic acid. So the same one we're seeing here. Alcohols can be converted to carboxylic acids by adding certain types of bacteria. Ethanol, alcohol, because of the OL, is converted into ethanoic acid. Carboxylic acids contain both a hydroxyl group, which is their OH, and then also a carbonoxyl group, which is their C double bonded to an O. The hydroxyl group and the carbonoxyl group group together to form a carboxyl functional group. This is what makes our carboxylic acid. So again, it's giving you an example. This is our ethanoic because we know right away there, and then we see two. How to name these? We see an ethane, but then we've got to take off that ending and add oic acid. Okay. So a special note about carboxylic acids, any carboxylic acid can react with water to form hydronium ions. So if we have a carboxylic acid and we add it to water, it could create those hydronium ions, which would, basically that's why it's considered an acid. Oops. So how we name these, it says they're named exactly the same way as alcohols, except the ending is not OL, it is oic acid. You will never need to address the need the address of the carboxylic group, so we don't need to put numbers because of the double bond. The carbon would be completely overloaded if they tried to put the carboxylic acid in the middle of the chain. Okay, so you will always see the very ending of the molecule be double bond O, single bond O, because the C would be connected there, and what it's saying is we have 1, 2, 3, 4 bonds. So if we tried to put that in the middle of a molecule, well, that would have to have a fifth bond, which would not make sense. Okay, so only 4 bonds that we can put there, so it's overloaded, and it has to go on the end of the molecule. So let's try some examples of these. This first one, Don't know why they're doing this one again, but it is a 2-carbon chain. So if we go to our booklet here, a 2-carbon chain is ethane, F. And I should put this farther this way because there's nothing we got to put in front of it. So if we write ethane, and then we notice that there is a double bonded O and a single bonded O, we literally just take that off and write oic acid. The next one, there's only 1 carbon, so if we remember 1 carbon is meth. We see that there is a double bonded O and a single bonded O on the very end. Well, the end is, there's only 1 carbon, so the end is the end. Also the beginning. This is our methane, because it's that. We take off that ending, like I said, and write oic acid. Right, so that's methanoic acid. And then let's try working backwards. It says draw propanoic acid. So propane, looking at this, we would say, well, propane means 3. So it's asking us to draw a 3-carbon chain. And then if it's an oic acid, we know there's got to be a double bonded O and a single bonded O on the end. I'm not going to draw the H's. That's basically all you need to do. If you really wanted to draw the H's, well, there would be 3 H's coming off that, 2 coming off that, 2 and 3. Okay, so that's how we would draw that, and this is our important part. Okay, that's our functional group. It's the double bonded O and the single bonded O on the end. So there's some practice problems on page 267 of your textbook. It should be up there on Mrs. Classroom. And I would like you to do number 21, A and B. And then there's also doing practice problem number 22. So there's some space there for you to do that, all right?